Professor Ravichandran,
Hello?
maybe what we can do is just have one person, everybody else can mute except for the speaker.
Okay, sir. Okay, sure. Hello.
I'm ready,
Respected,
sir. Hello?
you'll start the session. Hello.
Yes, we can start. Yes, we can start.
Respected Vice Chairman of Aruna Engineering College, respected Registrar, and respected Principal of Aruna Engineering Campus, I welcome you all for this wonderful occasion and extend my warm welcome to Dr. Krishnanand, Professor, Medley University. Welcome you, sir, for this wonderful occasion. On behalf of Aruna Engineering College, I once again welcome all the faculty members and my dear student community. Today's topic, it's a key topic, smart infrastructure, delivered by Dr. Krishnanand. He is having a rich experience in the civil engineering department. Hopefully, all the students can interact with him and try to learn more knowledge in the field of smart infrastructure in green environment. Hopefully, the entire world is simply migrated to eco-friendly houses with IoT connected devices. That's the new idea. Will bring out the global warming and other threats too for the forthcoming years. Hopefully, this session will enlighten the young budding engineers to enrich their knowledge in the recent trends. With these few words, I conclude my welcome address. Now, I invite our beloved principal, Dr. R. Ravichandran, to share few words about this webinar. Please, Professor.
Good morning to one and all present here. It's my pleasure to be part of this international webinar on green building principles and smart infrastructure. So we have Dr. Krishnanand Mailecheruvu, Professor, Department of Civil Engineering and Construction, Bradley University, Peoria, USA. So today, a lot of advancements have taken place in civil engineering and construction. Students must know what are the latest advancements beyond the curriculum. The curriculum is one part. And other than curriculum, what is happening latest? That is the job of every professional, every engineer too. So what after the studies, they must be aware of it. So in this connection, we have brought in the eminent chief guest, Krishnanand. So kindly make use of Professor Dr. Krishnanand. In this regard, I welcome the chief guest and wish you all good day. Thank you.
Now I request Professor to take care of the session and motivate them in the right direction. Welcome, Professor.
Thank you very much for the very kind introduction. My suggestion is that those of you who are not going to ask a question right away, maybe we can just mute so that there'll be no echo and they can move a little bit quickly. So I do have a small presentation that I wanted to share with you, which I'm going to do now. Today, what I wanted to do was talk about the green building principles and smart infrastructure. So I grew up in Tamil Nadu, actually, mostly in Chennai area. That's where I went, did all my schooling. Then I went to IIT Madras for my undergraduate degree, and then I came to this country, and then I've been teaching here and then Bradley University. So that is a little bit about my background. I've always been interested in environmental engineering, so civil engineering was one way to get into that. But then I'm also interested in LEED. I'm also interested in green building and smart infrastructure. So today's talk, I'll be talking a little bit about those principles, and I hope that you're all able to hear me. And if you have any questions, please unmute yourself and ask the question. So my talk, I have a tendency to talk a little bit more, so I'll try to keep that to a minimum. Most of my students always say that, even though they may like what I say, sometimes I go too much. So I'll try to keep that in mind. And some of the slides are more of pictorial slides, so I may be going quickly. But if there's any questions, there'll be some time at the end that you can ask me questions, okay? So the topic today then is green building principles and smart infrastructure. And what I'm going to do is we'll talk about where are we today? You know, what is the world like today? I know that that we have a lot of challenges, infrastructure challenges, but most importantly today, the health challenges because of COVID, especially in India, here also in the US, but especially in India now is a big concern for everybody. And then we have friends and family there also, so we're able to get those updates. So hope that you're still able to continue your studies, which is very important in this very difficult period. But because after this is over, again, somebody has to do the work, and hopefully you will get the training and do that work as well. So we have to define the reality today as far as what we are doing as a society and also globally. It doesn't matter whether it's in the USA or in Europe or in Africa or in India. Some of the problems are similar. And of course, the context is very, very different. So what works in Europe or what works in Africa may not work in India, and same thing in the US. So that understanding we should have. We'll also talk a little bit about sustainability and green building principles. What is green building? What is that? And what does sustainability mean in that context? We'll see some of that. What are some of the guiding principles of sustainability? And there's this term called LEED, L-E-E-D. You may have heard of it. If not, we'll talk a little bit about that today. And then we'll also discuss something about smart infrastructure and how this whole green building, sustainability, and smart infrastructure fit together. And then we can see some of the ideas how they can actually maybe fit into the smart infrastructure in the Indian context itself, because there the challenges are different, just like anywhere else. That's the thing that we have to think about. So the big question then becomes, can smart be green, or can green be smart? Green meaning more environmentally friendly, etc. So in other words, we are impacting the ecosystem less, we are impacting the climate change less, all of that. So those are the two related questions that we have to think about together when we discuss these kinds of ideas. So first we have to define the reality. For many, many decades, not just in the United States and not just in Europe and not just in Africa, not just in developed and undeveloped areas, but also in places which are very rapidly developing like India, China, and so on. We've been looking at mostly the resources. We're able to get them for cheap, and then we use a lot of materials. So we are what we call a consumer-based society or consumption-based society. And then from that, after that, what happens is that most of the time the wastes are just disposed of into the environment. And so the problem with this approach is that we don't put enough resource value on what we take. And then we also don't put enough value on where we put the waste, because we say, well, if it goes into the river, it's gone. It's out of my house, it's out of my sight. But then the next village down the line or next city down the line is going to be faced with dealing with that problem. So the idea, it doesn't work very well, but this is where we are as a human race. In spite of all the work that has been done, you still see that there are different parts of the world where you still have unsustainable systems. And the unsustainable systems are mostly because of high consumption. Even here in the US, the consumption rate is so high sometimes that the wastage rate is also very high, and there's challenges with that. So with that, what do we really mean by sustainability? You may have seen this diagram or something similar to that. So there are three legs, or it's called like a three-legged stool. One is the environment, the other one is economics, and the other one is the social side of it. So if something is satisfies the social side and the environment, then we call it bearable. So if something satisfies the social side and the economic side, we call it equitable, because there's a certain value there. And then when we talk about something which is satisfying the environment and the economic, we call it viable. That means it's okay to work and it's satisfying the economic side as well as the environment side. But unless we include all three of them, we won't get the sustainable. So this is a Venn diagram, basically, for those of you who have taken all these mathematics classes. And that just tells you that the sustainable section is a very tiny section in the middle, and that's where we should all aim to be. So now the same sustainability triad, you can also call it the triple bottom line. So people in the business world or people in the construction business and other fields, they call it the triple bottom line. So if it's very difficult to remember that other word, this is an easy way to remember. Other way to remember this is, they call it PPP, which is people, planet, and profit. So that's really how they think about it, which means that if you're able to address all the three things in any project, then you'll be able to do things in a way which is sustainable, which is really truly sustainable. So what is involved with the people? For example, improved human health. It can be air quality, water quality, and generally health. Okay, so that is a very significant thing. And we are seeing the effects of that, of a global pandemic today. And you can see how stressed some of our hospitals are and the healthcare system is around the world. The other thing is the decrease in crime. You know, we want that because if people are generally, they have what they need, then the chances of crime or the degree of crime will also decrease. And there's also lower burden on the local infrastructure. Local infrastructure means you can you don't have to have 50 police or 60 police or 70 police, but at the same time you can have a smaller cost related with that. And then you can also have less burden on the parks and less burden on all the other facilities that you have in that locality. For the planet side, that's easy for us to understand because it's related to the ecology, and you have to protect the all the species. That is important. So people are important, the planet is important, lower waste production is there. Is necessary for that. And then also you don't want to use too much of the natural resources, because if you use it completely, then you're not leaving enough for the next generation. So I always say that to my students that, I see that the young people in the world, whether they're in India or in this country, I think they sometimes are smarter than some of us, because they're able to understand that it is very important to choose things in a proper way and not waste things. So it's a very important thing. So these lessons you may learn from others, but you have to really practice them as well. And then the last one is the profit. So suppose unless you make something profitable, nobody will really go for that. It can be satisfying the people side and the planet side, but if you don't address the profit side, nobody will actually pay attention to that, or it won't go on for a long time. It's not going to be sustainable. So what are some organizations that are involved in this green building, which I'll talk about today? One is called the USGBC. There are other councils in other countries also. There's another one called LEED, L-E-E-D, and that's Leadership in Environmental Engineering and Design, Energy and Environmental Design. And that is a rating systems that puts building into different categories, and it's based on 7 fundamental principles. And the first fundamental principle there is actually global climate change. So it's a very significant part of how we design buildings, and I'll tell you why in a minute. And then there's also what is called the Green Building Business Certification, GBCI. That organization is the one that does all the certifications, and they also do accreditation of people. So what is a measure of sustainability? Well, one way of thinking about sustainability is it's the carrying capacity. And so that carrying capacity is what? It's the number of people that can be supported in a given area without significant deterioration of natural resources. What that means is you can have a sufficient number of people, but if you increase the number of people compared to the resources that are there, then you have a problem. So there has to be some kind of a distribution like that. So how can you actually change that? Suppose you have too many people in an area, you cannot do much about it. So one way you can change that is by having smart technology or smart infrastructure. So this is where technology comes in. The other thing that we have to keep in mind is that if we use the principles of circular economy and have more reduce, reuse, and recycle, then the environmental degradation also can be reduced, because otherwise it will shrink the carrying capacity. The second important idea that we have to understand is what is called the ecological footprint. So for example, how much resources a population consuming? And you'll be shocked to hear some of the numbers in the US versus some numbers in Europe. to some numbers in Africa, to some numbers in Asia, and also specifically in India. So the ecological footprint is very different in all of these different areas. And the trick is really how to maintain that and how to actually reduce that even more. That's a very critical thing. So why are these buildings important? Why is green building important? And why is LEED important? Because even today, chances are that you're inside an auditorium or somewhere inside a building, and that's how most people are. We move from one building to another building. So even though we may walk outside in the summer and do all those different things, but most of our lives we are spending in the building. And you can imagine in cold climates, people don't go out of the building, especially during the winter time. And so for about a few months, you just are pretty much mostly inside. And then they go outside. But even when they go outside during the other times, they would actually go pretty much from building to building. So 85% of the people spend 90% of the time inside. Why is that important? Because that's where energy consumption takes place. Did you know that 40% to 45% of the total energy consumption in the US and actually throughout the world happens because of buildings? So doesn't it make sense that if we are able to design the proper buildings, then we can cut down the amount of energy that is being used. When we cut down the energy that's being used, guess what? We have less emissions, less waste production, and less natural resource use, etc. So all of that comes into play. So even a small change in the percentage, let us say if it was 40% and it went down to say 30%, that's a big change. That can produce a tremendous amount of savings in all areas, starting with the environment. So that's something that LEED tries to promote. So how they do it is by giving certification and things like that. That's the process how they do that. What precipitated all this work was all this discussion was all the environmental climate crisis that happened. We all know about the global climate change that has been happening. People started to notice about the acid rain, the global warming, and the unpredictable cycle of droughts and floods. And I grew up in Chennai, so I know about the monsoon season. So imagine that if the monsoon season actually shifted, or changed in some way, a whole, more than 1 billion people can be affected by that. And we are seeing some effects of that, not in India, but in other parts of the world, including in this country. For example, where I live, in the US, in the western part of the US, most of the rainfall patterns have changed, so that what we are getting here in the Midwest is called the Midwest United States. You have too much rain, and in other places you're not getting enough rain. So that's also not a very good situation. You have energy crisis, loss of biodiversity, water crisis is there, and land and air pollution. So all of these problems, they're not just here in this country, but everywhere in the world, and that has to be something that we have to think about how to deal with it. So what happens when you do green buildings? Well, first thing that happens is that you have lower maintenance cost. You are not worried about maintenance. As maintenance boring, right? Maintenance is a big thing. You go and ask anybody who is in the management, and they'll tell you that as far as maintenance costs are concerned, it's one of the biggest places where they spend money. So 13% lower in maintenance cost means a lot of savings, okay? And no matter where in the world. 26% less energy use. That's huge. 27% higher level of occupant satisfaction. So by designing buildings properly, what you can do is to make people who are living there and working there more comfortable, which means that they will be working more, right? So that's why that's a very important part of it. And look at that last one, 33% lower CO2 emissions. That is a huge impact on climate change. So these are things that we can actually accomplish with green building. So then the question naturally comes, you're talking about green building and LEED, but what exactly is a green building? Well, a green building is something which is in its design, construction, or operation, it reduces or eliminates negative impacts. And not only that, it can create positive impacts on our climate and natural environments. So basically that diagram which I showed you earlier, where we were using a lot of resources, that doesn't happen. And where we produce a lot of waste, that also doesn't happen. or at least if it happens to a smaller extent when we use green buildings. So what are the features that make a building green specifically? One is efficient use of resources, and you can see the list here, using solar energy, renewable energy, reuse, recycle, indoor air quality. All of these different aspects are there. And all of this means that we also have to have smart design. And this smart design really has to deal with the whole infrastructure, not just one building, but the entire urban structure, infrastructure, or entire regional infrastructure. And so that design has to adapt, has to enable adaptation to a changing environment. That's a very, very significant thing that we have to think about. So because of the fact that an average person spends 85% of their time indoors, buildings actually use 1/3 of the total energy demand worldwide. 2/3 of the total electricity consumed. In some places, it's more like 73%, 75%. And 1/8 of the total water consumed. That's a lot of water, right? And so that's something that we have to say, if we focus on this particular problem and solve it, and then build from there into the infrastructure and then get into the smart infrastructure, then we'll be making a pretty big impact on how we are affecting the planet and how actually we are going to change the way that we live in this world. So we have traditional design where you have linear, you do one step, next step, next step, next step. That's one way to do it. So sustainable design and construction is not like that. So what they do there is, see, in a traditional construction project, a civil engineering construction, what they would do is first they would have a plan, then they would go to the owner, they would get approvals, do step by step, they would kind of do all of that. But here, the difference in this green building idea, which is sustainable design, is that at the very beginning of the project, everybody gets together. The owner gets together, the designer, the architect, everybody, and including a sustainability professional, and all of them get together to see how they can look at the building from a life cycle perspective. And when I say building, you can extend that same thing to urban infrastructure. So go from one building to many buildings. And that's how you get into the smart infrastructure as well, which we'll see in a little bit. So what we have to do here, the thing we have to think about is that we have to integrate design of civil, architectural, mechanical systems at the very early stage. Civil engineering is not just civil engineering and construction, but there are all disciplines of engineering are involved. Electrical engineering is involved, mechanical engineering is involved, industrial engineering is involved, production engineering, all kinds of different areas are involved. I just said a few. I mean, if I say that the whole list, it'll take me a long time, but you can understand. Not only that, there's a lot of scientists also who get into this area. So we call it the built environment. And so I'm not going to talk too much about this. I'll skip these few slides. It gets into a lot of detail, but it just talks about, it's a very good resource. So some of you can actually read this and learn a little bit more if you're more interested in it. It talks about the tactical level implementation of building environment. How do you make it sustainable? So you have a sustainable planning phase, you have a sustainable design phase, sustainable construction phase, sustainable operation phase. What is one common thing throughout? That it is sustainable. That's what makes it work. And so these are all the details of that which we'll skip. And you can see, some of these elements that you can see, especially in the operation and maintenance, is where you get into electrical engineering aspects, the mechanical engineering, and so on. So what we look at in green building design is looking at the life cycle assessment. And life cycle assessment means mainly what materials are you using, where are you getting them from, how much energy are you using for bringing the product from where it is produced, like raw material or ore, to the finished product. And then what are the emissions, what kind of waste is being produced, air waste, water waste, solid waste, all of these things are important. The next very important thing is life cycle cost. And so this life cycle cost really makes it very different. Why? Because it brings into the picture the economics. See, most of the time when we talk about life cycle analysis, etc., life cycle assessment, people are only talking about emissions and the environment, etc. But unless you deal with, and then maybe the social side of it and people, but unless you bring in the economic component, it's not going to work. So that's the difference here. So there is something called the cradle to grave approach. Have you heard of that? So cradle to grave approach means that we are looking at something where we take some material, use it, and then after it's done, we throw it away. Another approach is cradle to cradle. We take some material, you reuse it, and then at the end of its life, we use it for something else. So that is called cradle to cradle. We don't throw it away. In India, we have a very rich tradition of doing that. The cradle, we don't call it that, but this is something which is kind of inherent in the Indian economy. But I think that is something that has to come back in a conscious way as well. So the initial costs you can control. You have to think about that. Human health is important. Productivity, how much work is being done for the amount of time that is being spent, etc., and the amount of investment that is being made. And can you use this the waste from when you construct a building? Most of the time it's on an old building site, right? So you break the bricks and break all of that. Can you reuse some of that? And then the question is, can you reuse it in a smart way? So those are things that we talk about when we say construction and demolition waste. So green building design principles, you see the very first one that is called embodied energy. That's a big one. It just doesn't include the amount of material needed to make some product, but it looks at all of the energy that went into making it. That's the big thing. The rest of them are also there. And then the next one is what is called flexible design. So the flexibility is a big thing in green buildings, which means that you want to minimize the environmental and economic impacts, which means that you're going to more towards the sustainability side of things. And then you also have what is called adaptive reuse, which means that suppose you have a building that part of it you can use, you should use it instead of just breaking it down completely and putting a new structure there. Sometimes you have to do that. You don't have a choice. But if you're able to reuse a building or part of a building, you certainly should do that. And that's what the green building design really is about. Regenerative products. Now, can you imagine that the building, electricity consumption in buildings is very high? It's very common, right? To understand, you can understand that. You saw that the cost can be 26% or to 33% lower, depending on how you look at it, with green building. But green buildings can also generate electricity. Think about that. So there are buildings that actually generate electricity and give it back to the grid. So they produce excess electricity, so give it back to the grid. And then what happens is that during the time that they have demand, they will take the energy from there. So this is a very interesting and unique way of doing things. And in a place like India and other parts of the world also, where we have these rolling blackouts, these regenerative projects may be something which may be very important for us to look at more seriously. Then, of course, you have the regenerative projects which will have net zero energy. That means they won't use any more energy than they produce on site. That's the best thing you can have, which means that now the necessity for using a lot of electricity from outside is gone, right? I mean, imagine living in a building like that. So that's where we kind of need to be going. And then, of course, there are more details which I won't get into here. So how is this green measured? Well, it's very important in engineering to always have, and science, to measure things. Why? Because if I say I'm doing it nicely, I'm doing it well, you should ask me the question, how do you know you're doing it nicely? Or how do you know you're doing it well? Then I have to say, well, I'm measuring the success by seeing this much production is there or something else is going down. So unless that measurement is there, there's no use of this technology or whatever we are doing. So I have some friends at Caterpillar engineering company. The headquarters is here in Peoria. You may have heard of that company. It's the largest company in the world in terms of all the equipment that they manufacture for earth moving and so on. They use a lot in construction and engineering practice. So they tell me that they're very big on quality control, and they say that if I cannot measure it, I don't even design it. So that's the way that they really look at it. So the measurement is very important for them, because otherwise they won't know whether they've done the right thing or not. Now, LEED itself is the is the vehicle by which you can certify the buildings. And today, it started back in 1993. And today, since 2016, we have what is called LEED version 4 or V4 at the very bottom you see. And there you have very much stricter requirements for improvement in carbon reduction and human health, and incorporating technologies and looking at new government policies and standards. All of these have been brought into the way that you have to do the approval process for or certification of a building for a particular kind of a grade there. So just so you know, as far as LEED is concerned, there are 4 categories of building. One is called just LEED certified. The other one is called the silver. The third one is called gold, and the fourth one is called platinum certified. So you just have to get so many points, and that points you earn by basically showing or documenting where the energy is being saved. And remember, why is this being done? Because if you save energy, you save materials, and you make it more economic and more environmental friendly, you're impacting the global climate change in a very significant way. That's the overall thinking there. So sustainability thinking means that we have 3 things which have to happen. One is systems thinking, and this gets into the smart infrastructure in a way. We'll see that again more in detail a little bit. Systems thinking is important. What does systems thinking mean? It means that I cannot think of myself as just one person, as an example. I'm working in a college. So it's not me, it's the people who I work with. It's not only the people I work with, it's the students. So not only the students, the staff is there, the people who help are there. All this is the system, the university system. That's an example. So similarly, in a city, you have to have a city thinking. You have to have a systems thinking in the city. At the regional level, same thing. At the state level, the same thing, and like that. So the systems thinking idea has to be there, and it has to be brought into engineering in a very significant way. It's very, very important for future engineers to understand how to incorporate systems thinking. When you're designing something, you just cannot design only one small part. You have to know exactly how it fits into the whole picture. The other important thing to keep in mind is the life cycle. So you have to have life cycle thinking. You cannot just say, I'm just going to get this from here, from him, I'm going to buy it, and this one I'm going to sell. That may be part of what you're doing, but you also have to think about, when I'm buying from this person, what is the cost of that? So what is the environmental cost of that? What is the materials that are being used? How much waste is being produced? All of that. And when I sell it to this person, or this company, what are they doing with that product? So you have to have a kind of a global way to think. So that life cycle thinking is important. And then integrated process, the third idea there, is a concept that emphasizes the importance of communication. So I have to communicate with them, they have to communicate with me. And you see that word stakeholder, that's a common word today in engineering. And it's actually something that we use in partnership with our business partners, and also industry partners, and also people in the government. Stakeholder simply means anybody who has an interest in an idea. For example, let us say that you make some product. Let us say you make furniture. So you make tables, or wooden tables and wooden chairs, right? Who are all the people there? Who are all the stakeholders? In that case, the stakeholder would be the person who uses the table at the end or buys the table. That's the consumer. The person who makes the table, maybe a carpenter. Somebody who produces the wood, and cuts the wood and brings it to you. Somebody who processes the wood, somebody who sells the product. So all of these are different stakeholders. So what we have to do is to make sure that we bring all of them. So that's a simple example. In the case of a building or a civil engineering project, here you'll have a civil engineer, you'll have a construction manager, you'll have the owner. Of course, the owner is the biggest one. And then the next after that, you'll have people who are sustainability experts. You'll have hydrologists, you'll have mechanical engineer, you'll have industrial engineer, you'll have electrical engineer, and you'll also have people from other fields, sometimes in physics and biology, who are needed for projects, especially in the sustainability area. And in addition to that, you'll need people with business backgrounds and so on. So all of these are what we call the stakeholders. And so this integrated process means that they come together at the beginning, plan it so that they're going to go through that process completely. They don't change what they want to do in the middle. So there's the LCA and LCC. I've described both of them. Now in the technology area, what we do, and this is where the field is moving, is we have what is called building information modeling. And you may have heard of this phrase before in some of your classes, or maybe you'll hear about it if you read on your own also, is what is called 3D BIM, which is basically XYZ, virtual reality. 4D BIM means that you're adding the element of time to 3D, and 5D means that you're adding cost and time to the 3D BIM. So this is a very sophisticated way of looking at projects, and this is the bridge into the smart infrastructure projects. How we actually include the time, how we include the cost. When we are integrating technologies, say when we talk about smart systems, we may say, okay, we have to know automated controls have to be there. And so the time factor is involved, and there's a lot of software writing that goes in. So it becomes a very complicated system. But one of the primary things that this building information modeling does is it allows the people who are involved in that design to identify problems very early on and then avoid them. So that's a very significant thing that they do. Then you look at some of the issues, we have seen some of these: human health, social issues, climate change, ecology, and energy economics, and others. These are all things that we look at in green building. So in policy measures, when we establish them, we have to work with people in the government all the time, because they set the policy, and you have to follow the regulations from that. So there are a lot of different things that we work with them, and you can see some of those aspects here. So smart infrastructure. So now we go from the green building, and we are now transitioning into the smart infrastructure space. So that BIM is a way for us to get into this, BIM meaning building information modeling, but smart infrastructure is much more than that. So smart infrastructure really talks about, we are looking at several operatives from several domains of activity: energy, public transport, public safety. Those are only three. There are many, many others. And the fabric of it is trying to achieve automated control in some way or the other. So in other words, it's a very data rich, or you have to be very good in data mining, data control. So this is where artificial intelligence comes in. This is where computer science comes in. So today, civil engineering is very different than the civil engineering I learned, about 30 years ago. So we're incorporating all of this, and it's a very increasingly data-driven field. So that's why we have to look at what are called cyber physical systems and see how we can operate. So within that, this is the European approach. They look at smart cities, smart homes, smart hospitals, and smart grids. So all of these, they have different meanings, certainly, but smart cities, they're looking at the whole urban infrastructure. Smart homes mean, how do you make sure that your home is using the least amount of energy, et cetera, all of those things. Smart hospitals the same way, how are they optimizing it? Smart grids deals with electricity use, very important for countries where you have power shortages, right? So these are ways that we can look at it. So smart city, for example, would have all of these aspects. If you look at this is, you have traffic management, education, air pollution, open data, all of this. And what is tying everything together? It's the data. Okay, it's the data that you're getting from everywhere. You're putting into this system and then coming up with it. If you go back about 20 years, they never had geographical information systems and other things for cities. But today it's very common to have that. And so GIS allows the smart city to be incorporated and develop much better, in a very significant way. So you can see all of the infrastructure there. Smart home is there, smart street lights, electrical vehicle charging. So I have many friends here who drive electric cars. Okay, for them, they don't use any gasoline, but what they need is some kind of a plug where they can actually charge their vehicles also. So those are all things that are there already, and they're not very common, by the way, even here. But those are things which are happening very rapidly around the world. So smart infrastructure, then when we look at it with the European approach, they say there's the private and non-public, there's the non-transport operators and the non-op. So this is one way that they just look at it for the transportation side of it. Similarly, there are others as well, which we'll look at. So, we were talking about, I think in the beginning, somebody had mentioned about IoT, right? The Internet of Things. So this IoT is a very important and emerging field for us. It has changed the way that we do any engineering, including civil engineering. And there are lots of examples of that. Just for doing that, we would need, one full hour. But when you look at the IoT monitoring for smart community, the way that it works is that you can see how complicated this. It's all data driven. It's all based on how the data is collected, how it is synthesized, how it is mined, what kind of algorithms are there to see patterns. So all of that. So there's a very rich area where you're looking at the traditional civil engineering, construction, other engineering, and then also layered in with AI and also computer science. So you cannot, you're getting into the space where sort of all of these fields are coming together. So it's a very important area for us. Now we look at smart growth principles, right? And so how can we incorporate this? See, you can have all the smart technology, smart infrastructure, etc., but people still have to live. And so when people have to live in an area, what we want to do is to provide them with with ways in which the city can grow. So in the urban planning area, for example, we may have eco-industrial park development. This is very common in Europe and other areas of the world. You can have green cluster developments, which means that you have dense development. And LEED and other green building principles encourage that, because if you have everything close to each other, you don't have to go 10 miles from your home to work and then come back 10 miles. In some places in the United States, it's bigger than that. And that's not a very healthy way to live. So if you have more dense economic development, it's better. Then you have this eco-village idea, and then this brownfield. And brownfield simply means here that it's an old industrial field. Some industry was there, a manufacturing company was there, it went out of business, and it's just sitting there. And so what happens is that it usually becomes a land where people go and dump waste, right? That's what I've seen in India, and here also the same thing. It's no different. So it becomes an eyesore. So what happens is that if the city government can take charge of that and just redevelop that, you don't have to clean it to super clean levels, but just minimum levels, so that another industry can move in, then that is what is called the brownfield. So your investment is small from a business side, but the gain is a lot, because now you're revamping the whole ecosystem of that place. When I say ecosystem, it's not like plants, but I'm talking about the people and the urban areas and everything else around it. So when we look at the smart cities, what are some infrastructure elements that we have to have? Adequate water supply, right? We still need water to live. We have to have electricity supply, and that's a challenge in many parts of the world. Even here, there have been some cases where we have had rolling blackouts. So that's not something which we want to avoid that if we can. Sanitation, which is a big thing, including solid waste management. And this is an area that I've done some work in India also. I do some work with some professors in IIT Bombay on this. With landfills and so on there. And we're trying to they're trying to come up with a way to produce zero waste. And so they're very far ahead of everybody else, including people in the West. So most of the work is done in those areas, including in IIT Madras also. Urban mobility and public transport, affordable housing for the poor. Then you have robust IT connectivity and digitalization. That's a link that connects everything. Good governance has to be there. And e-governance means what? Means that instead of us going individually to pay our taxes or do different things, we can try to do this electronically if possible, which means that cybersecurity becomes very important, right? So cybersecurity, if you don't have cybersecurity, you cannot really do any of this. So When I went to India, the last time I was there was in 2019, before the COVID. And during that time, I saw that all the banking, almost everything, you have to, they would send you a code, and then it's just a code for that particular transaction, and then you would actually do that. That was not being done here in this country. So in that sense, India was ahead of the US there. But now slowly here also they're adopting those practices, and all regular banks are doing that, mainly because they want to prevent fraud and things like that. So cybersecurity is very, very big in civil engineering, actually in all engineering today. And sustainable environment, I cannot say enough about. So if you tell me to talk, I can talk about that for days. That's very significant and important, because if you don't have that sustainable environment, you cannot survive for very long. Safety and security of citizens, this is where people come in, the people side of it, the people, planet, and profit, right? So all three are important. Women, children, and elderly, you have to protect them and make them feel safe. Also health and education. So in this country, even though they say the healthcare system is very great, the cost of healthcare is very, very high. So it's very difficult for some of the poor people to afford any decent healthcare, even here. And you can imagine what it is like in other parts of the world. So why smart cities then? Why should we think about smart cities? When we talk about smart cities, we want to, number one, promote economic growth. Second is improve the quality of life. And the third, very significant thing, which makes smart cities smart, is to use technology to develop smart solutions. That means we integrate data management into governance. That is the big thing, okay? So that's the thing. There are many sustainable city movements. So sustainable city movements, their idea was more with respect to the environmental sustainability, the people, profit, and public area, and the planet. But the idea here is to go beyond that also when we talk about smart infrastructure and say, can we have a marriage between this traditional sustainable, now we're calling it traditional, a few years ago it wasn't there. So when we look at the sustainable city movements, and can you look at that from a standpoint of how you do it for smart infrastructure? So in the case of India, I mean, there's been a lot of progress in different areas. I've been following that to some extent. And the idea there is, it's like 4 pillars they typically talk about. One is the comprehensive development, which is based on the institutional side of it. So it has to be, very structured that way. Then they also look at the physical, the urban ecosystem. On a physical level, they look at the social structure and the economics. Again, when you look at these 4, what do you see? You see the same 3 things, right? What are those? The triple bottom line. One is people, the second one is planet, the third one is profit. So that's basically what they're looking at here in different ways. So those 3 don't leave us. So those sustainability principles never leave us. So in India, what are the types of things that we might want to look at? One is adequate water supply, assured electricity supply, sanitation, mobility, all of the things that we've talked about before. But these are especially important in places like India, where we are looking at how to move to the next generation of technologies, and how the society itself is being transformed fundamentally because of technology here. So when we look at the smart growth principles, what we have to do is, and the smart growth principles here I'm talking about is more from the standpoint of sustainability rather than just purely the technology. So we have to see how can we use land in a smart way so that we can still have development and we can have preserve the environment at the same time and keep things safe for people, from the public. And how do we do this with smart infrastructure solutions? The way we can do this is, for example, through e-governance and citizen services. So if we promote those, then the amount of the way the efficiency of the system improves. Energy management, big thing. And then environment and ecology protection, very significant. And when we look at water and waste management, those are also significant. transportation networks, I mean roads and highways, and not only that, but the entire system of rapid transit, or even regular bus services and trains. Those are important. And then ultimately the social development has to be addressed very seriously, otherwise nothing will work. So what we have to look at, and I'll speed up through this process a little bit here. So when we look at the e-government and and citizen services, these are the kinds of things that we look at. So ultimately, we have to look at how the data is managed, how it is stored, essentially the cybersecurity part of it. When we talk about environment and ecology, the protection of that, you're looking at air pollution, urban wetlands, parks and greens. Biosphere is a particular type of like small garden that you can have in a city. And then the heat island effect. And if you go to many cities in the United States or anywhere around the world, you'll see that cities are usually much hotter than the surrounding areas. The same thing is true in India also. I remember that I used to be living inside the IIT Bombay campus, and it was at least 4 or 5 degrees cooler. And then as soon as we went out of the campus into the city, into Powai and other places, suddenly the temperature seems like it was very high. So there's a reason for that, because when you have, we have what are called heat island effects that happen in cities, and what we want to do is to reduce them. And smart cities can do that, because if you have sensors, if you have different technologies available, then they can adjust which part of the city is going to get what. That's the way that we can think about it. So we have to look completely in a different way than what we are used to today. So what we want to do ultimately is to go to this model. From that first model, if you remember, we want to go to this model, which is we want to have values that are resources that are valued, low throughput society, don't use much. So go from consumer-based society to a society which is not completely dependent on consumerism. You cannot avoid consumerism, but try to limit that. It's a very philosophical thing, actually, and it's very embedded in the Indian culture. So you use what you need is really what we are saying. And then reduce, reuse, recycle. And this next thing which you see down here, this industrial management process here, that is basically what we call our industrial ecology principles. So then we substitute. This is where technology comes in. So you guys will come in as engineers and scientists, and then social policy makers and things like that, and you'll come up and try to find technology solutions. And then public policy people will look at this part, putting permit fees and things like that, so that it becomes expensive for people to produce waste. If it becomes expensive to produce waste, you know what a factory will do, or what a company will do, manufacturing company? They will produce less waste because they're spending money otherwise. So that's the way to kind of do that. So you're seeing, pollution like this. Look at that. I remember going to Cairo, maybe in 2009. I went there to teach a class. It was hydraulics or something, water supply and hydraulics, I remember. But when I looked at from, one of the places where it was a slightly higher elevation in the city, I went up there, and there you could see the whole smog. In Cairo, just like in many of the Indian cities, the amount of traffic is extremely high, and just the amount, the smog was just that thick. And you can imagine the water quality, air quality in those cities. And so that's something that we have to avoid. Temperature increases, and you're seeing all these changes happening everywhere around the world. So these are very significant things, and these are from NASA, the National Aeronautics and Science Administration, the one that sends the space. So they have their own data wing for all the climate. So this is what it is. So what can we do? These are some examples of some technologies that we can use in urban areas. So, if you have urban gardens of different kinds, these are called green roofs, etc. They're literally green roofs. You can see that, right? There are some here even, in a colder climate like that, except it takes a lot more money to maintain them. But people actually find that economically overall, it's worth it for them to do that. Then there's also other ways. When you have energy management, you You can build don't build too big of a building, but build a building which is big enough for you. Don't make it bigger than you want. You have smart meters. You use smart meters so that you can actually know how much energy is being consumed, and so from that you can have the technology can say, send a signal saying that, hey, these people are using too much energy. So then you talk to them, and then try to come up with a way to reduce the energy consumption. Renewable energy. It's the more renewable energy you use, the better off you are. And there's so much of that. Energy efficient green buildings, very significant, and there's a whole technology that's associated with that as well. And there's also this off-peaking, which means basically that sometimes what happens is that when why there is the electricity company would charge a lot of money, right? And there's no way to store AC power, right? So as a result, what happens is that when they produce the AC power, immediately it goes to the consumer and they have to use it. So if there's high demand, they have to produce more energy. And how do they produce energy? They may use coal, they may use other kinds of energy sources. So if you want to reduce the coal consumption, right, what you have to do is to say, instead of having one peak like that and then going all the way down, you can make that peak go down. So you can have a flat peak like that. What they were talking about in this COVID crisis also, they said, we want to reduce the peak and make it big so that, we can manage the people in the hospital and all of that at the beginning of the COVID crisis. That same idea applies also to energy management. So if you're able to reduce the peak by changing consumption patterns, that's a very useful way to do this. So then you have greenhouse, building energy. So you try to prevent that. You have windmills, and you can trap the energy using that. Hydroelectric power, and you can do the hydroelectric power not just in big dams, but you can also have smaller systems inside buildings too. In a very creative way, you can come up with things to do. You can also have solar water heaters. These are common even in India and other places. I can see them. Also, they have these point of use, immediate heating kind of elements, rather than having a storage, heating the water, storing it, and then using it. So that's the old way of doing it, but these are the more newer ways of doing them. And of course, photovoltaic cells, which some of you may be interested in. There's a lot more to be done there. Battery technology is really one of the things that, as a whole human race, we still have a lot to do, even though we have a lot of advancements that have happened, photovoltaic cells and so on, but we still are not there, and that's really one of the stumbling blocks. So maybe one of you in your group can actually do this. Look at all these solar power generators in different parts of the world. This is a case of smart building. So here again, you're using the idea of this is like an anthill. The idea came from an anthill. Can you imagine? So by sometimes just observing what happens in nature, we can actually have very smart designs. So this is also another smart design to cut down the energy use in buildings. So this is how they operate in cooling and heating mode, both of them. You can see that. And then this next one here you see is more of fuel cell. This fuel cell technology is coming up and being used in different places, but it's really still, it has a ways to go before it can be that's impactful. That's really one of the things that needs a little bit of extra research and also extra work in that area. Then you look at water and waste management. There also you can have smart meters, leakage detection system, especially for water. Did you know that there are some cities, I'm not talking about India, I'm talking about in the United States and other developed countries, where almost 30 to 50% of the water they produce, that means what happens is that they get the water from the river or groundwater, they clean it, 30 to 50% of that water is wasted because of the leaks in the pipes, and by the time it reaches the consumer. So that's a very terrible thing, right? You're wasting money for treating the water, then you're wasting it because it's not reaching the consumer. Consumer meaning the people in the houses or or different companies, etc. So that kind of a waste is something which we can certainly do something about. So therefore, the leak detection systems, again, it's a smart technology. How we do that. I know that some of the people, very young people, in fact, high school people in Seattle, I know, are working on these leak detection systems for pipes. So they came up with some very, very innovative ideas using robots and other things like that, and also IoT technologies. So these are things that are coming up that we have to tap into. And of course, the waste to energy is also there. So this is a case where we look at the entire energy or the what happens inside a city in terms of waste control and water control. Look at all the different places where all the data is being collected, and then look at the loggers for pressure monitoring and so on. And you see all of this, and you have to have some way to use that data. So that's where the magic really happens. Smart water is important, which means that all of the ways to detect leaks, etc. And even in places where you don't have much rainfall, you can actually have very nice green gardens if you manage your systems properly. And this slide is something which is similar, which is something I know a little bit about with respect to the waste to energy aspect. Ultimately, what you do is after, this is for solid waste, you can actually take out all you can and then come up with doing the, converting the whatever's left behind into energy. So these are the things that we can do. And then I have the final few slides here dealing with intelligent transportation systems. So when we look at these smart transportation networks, I mean, today we are looking at automatic cars and self-driven cars and so on. They're not there yet because they still have a lot of problems in terms of operational aspects, but things are coming into play. So these are things that are happening. But more importantly, when it comes to transportation networks, the kinds of things which make things work for us would be urban transit of various kinds, rails, etc., streets. And when you have streets and when you have dense population centers, that means you're promoting people walking rather than taking the bus or taking a car or something else, or taking a taxi or an auto. And then what you do with that is when people walk, they're able to, their health also improves. So these are all the things that you want to improve, cut down on the traffic congestion here. And then finally, when we look at social development, that's a big part of it. You have to look at telemedicine. Can we do that? Teleeducation, can we do that? Can we do business incubation centers? All of this we can do. And that will help people gain the skills to be productive and start their own businesses and be very productive citizens on their own. So when we put all of this together, what we see is something like this. So we are looking at the start of a comfortable day, want smart commuting to work and school. You have eco offices, that means places where you can live and work very nicely and comfortably. That means your production level will also be high. You have lively communities, so social interaction there. Parks, that means you're looking at the ecology and also the social side of it. Then 24/7 healthcare means that you have access to good healthcare. Waste-free shopping, that means you have shopping centers that are that don't generate much waste. And then at the end of the day, you can come back home, and then in the home also you have a smart home, which means that you're using less materials, less energy, and also producing less pollution. And hopefully in some of these buildings, you're producing energy, then you're giving back to the grid when you don't need it. So those are the kinds of principles that we need. So we have to integrate the principles of circular economy into all of this, which means that we try to extract as much energy as possible or as much use of as possible. There are 9 principles there to get into that. So that's a topic of another, maybe another hour or so. I'm not going to get into that here, but I just wanted to tell you that in closing, we have the green building. We started out with green building because it was very important to recognize that that's where a lot of energy materials goes in, 40% of the energy, so many percent of the building materials and so on. So if we are able to make an impact there, we can certainly change the what is happening in the environment. And how do we do that? we can use that using data. And so that when we talk about data, that's where the smart infrastructure comes in. And then the way that we integrate the cyber, the data and the data mining and all of the AI into these civil infrastructure systems, that will help us to manage these systems better. We cut down on the waste more. And then, of course, you have to think about the cyber security, because we also have to think about protecting the data also from falling into the wrong hands and things like that. So all through, you'll see that green building and sustainability are very, very closely connected, and they lend themselves to be managed very well by these smart infrastructure systems. So that's where the future is going. And I know that you are going to be very smart people, all of you, and some of you may be working in different areas. And if you decide to do that, you can see how all of these things are coming together in this slide, right? You see electronics engineering, you see software, computer science, you see mechanical engineering, electrical engineering, civil engineering, all kinds of different areas coming together. And then this is where we're going to be living. So the better off we are with that systems thinking approach, which I talked about before, rather than just, I'm only going to do this and not that. If you have a systems approach, then you're able to think like somebody who knows what is happening in other areas, and then knows what to adjust in your particular section of your project, so that you produce less waste, and you're also using smart technology to do that. So these are things that I want to leave you with, these thoughts. There are just some pictures, so you can see that this is the last slide I have. So the top picture is about from Peoria. This is taken on the river. A river actually goes through here, and that Chennai in Elliott's Beach is kind of where I grew up, near there. So I used to go there quite often. So that I captured the sunrise one day from when I went on one of my trips there. So with that, I'm going to stop finish my presentation here and see if you have any questions.
Students, if you have any queries, please ask. Professor will elaborate. Any queries from student side? You can note down Professor's mail ID. You can contact him at any time. He will elaborate all the innovative practices in smart infrastructures. Thank you so much, Professor, for spending your valuable time with us and elaborated all the key factors related to smart infrastructure and the green environment. So future, there is a lot of scope for integrating IoT, AWS cloud along with mud houses. People can comfortably live for the forthcoming years. And there is another huge challenge, how to get rid of from COVID situation too. Thanks for your valuable time, Professor. Thank you so much.
Yeah. Well, thank you very much, and have a good rest of the program also for you.
Thank you, Professor. We'll wind up the session. Thank you. Bye.
ப்ரோக்ராம் முடிஞ்சிட்டு போய் எதுக்கு உள்ள காணுங்க